Hello, good morning, student. Today we are going to start the most important question of nature of matter. Here is the question one: when two ice cubes pressed, they join together. When two ice cubes pressed, they join together. Explain the principle involved. Okay. Here is the question meaning is that we have here over the two ice cubes. Two ice cubes. For example, these are two ice cubes. One ice cube this and one ice cube this. Now we are going to applying the pressure over this and over here. Then we get this ice cubes joined together to each other. What is the reason behind it? The reason behind it is that when we press two ice cubes, here is the pressure applying. When two ice cubes join together by applying the pressure, so the melting point at the joining part. This is the joining part. The melting point at the joining part reduces. But after removal the applying pressure, the joining part recovers its melting point and it started to convert into again the ice. First, again I want to explain it again. When two ice cubes join together by the help of the pressure, by applying the pressure, then we get that this joining part reduces its melting point, and this joining part starting to convert it into the water. But after removal the pressure, we get that the joining part start to recover its melting point. Then the ice cube starting to convert it into the ice. That's why this attach this two, one this and this two, these two cubes starting to join each other and they attach to each other. That's why. That's okay. The second question is this: what is the critical temperature? How does it affect the liquefaction of gas? Second question is what? Here is we have to define the critical temperature, definition of critical temperature, and provide the reason behind it. How does it affect? Provide the you will have to tell the effect, the liquefaction of the gas. Okay, so first of all we need to understand what is the critical temperature. So I can explain it. Suppose that this is the line of critical temperature. Okay, critical temperature is what? The temperature below which a gas can be converted into the liquid, that is known as the critical temperature. And the pressure below this, and the pressure, the gas, again I want to describe it. The gas below which the temperature below which any gas get converted into the liquid by applying the pressure, this is known as the critical temperature, and this applying pressure is known as the critical pressure. Okay, so for example we have CO2 gas. Okay, the critical temperature of this gas is 31 degrees centigrade. Okay, we know that the critical temperature of this gas is 31 degrees centigrade. So below this critical temperature, it can be converted into the liquid only by applying the force, pressure, and this pressure is known as the critical pressure. Understand? So how does it affect the liquefaction of the gas? We can understand it by as much the critical temperature, as much higher the critical temperature, so higher the force of attraction. Force of attraction. So higher the force of attraction. Then when the force of attraction increases, critical temperature is also increases. Then the when the critical temperature increases, then the force of attraction is also increases. That means the critical pressure decreases. Critical pressure decreases. That means uh, higher the critical temperature, higher the force of attraction, lower the critical pressure, and easier the liquefaction of the gas. That means easier the liquefaction of the gas. Okay, that's okay. This question is final, and this question is going to start question third. This is the question third. This is question 1, this is question 2, and this is question 4. Okay. Is it possible to liquefy CO2 gas at 50 degree? Give the reason. No, it is not possible to convert CO2 gas into liquid at 50 degree because the critical temperature of the CO2 gas is 31 degree. That means that this is the line of critical temperature and the critical temperature of CO2 is what? It is 31 degree. Below this temperature, the CO2 gas can be converted into the liquid by using the pressure, and this pressure is known as critical pressure. But above this temperature, the CO2 gas cannot be converted into the liquid. That is known as the upper limit of the critical temperature, and the critical temperature limit is 31 degrees centigrade. But above this temperature, this CO2 gas cannot be converted into the liquid. Understand? Because the critical temperature of this gas is 31 degrees centigrade. And the fourth question going to start. Why are the cotton clothes preferable in summer season? Why are the cotton clothes preferable in summer season? In summer season, the main point is that over here we need to understand what is the absorbing capacity of the cotton cloth. For example, this is the cotton cloth. This is the cotton cloth. It has the very good absorbing capacity, to absorb water or sweat. It is holding the very good capacity, holding a good capacity to absorb the water and sweat. In summer season, when we getting the sweat getting out the sweat from our body, then the sweat is absorbed by this cotton cloth, and after that it take all the sweat on the surface of this of this clothes, and after that evaporation takes place, and cooling effect involved over here. And cooling effect, we feel the cooling effect because of the evaporation, because of the evaporation over here, then we feel the cooling effect. So the cotton cloth is preferable in the summer season. Okay, thank you.